Hello and welcome, my name is Amir, and in this video we're going to solve the puzzle on day 2 of the Advent of Code 2023. We will be using JavaScript, and so let's go and see what we are facing for today. So if I press 2 here, and let's go a little bit down. Okay, the game starts here. The elf shows you a small bag and some cubes which are either of these colors. Each time you play the game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay, so to get the information, once a bag has been loaded with cubes, the elf will reach out into the bag, grab a handful of cubes and show them to you, and then put them back inside the bag. Okay, so this means that after each try, the number of the cubes is the same. It doesn't change. He'll do this for a few times. Great. You play several games and record the information for each game, which is the puzzle input, something like this. And each game has an ID, which is this number. So for example, this. In game 1, 3 sets of cubes are revealed from the bag. These 3. So game 1, in the first try, we get 3 blues, 4 reds. In the second try, we get 1 red and 2 green and 6 blues. And in the last try, we would get only 2 greens. Same here, and same here. Okay, so this is the input. I believe we need to have a lot of mapping and probably reducing here and there. The elf would first like to know which games would have been possible if the bag contained only these values. Okay, so I need to go here and check to see which of these games is possible. And possible means that, for example, this here says 12 red cubes. I would go here and see the number of reds. Here I have 4, here I have 1, and only these 2. So reds are okay. Greens are, I get 2 greens and 2 greens here, so greens are also okay. Blue is 14, 3 blues here and 6 here, so it's okay. And so for example, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. Let's go to this one. We get 8, 6 and 20. Okay, so here it says that he has shown us 20 red cubes, but here it says that there are only 12 red cubes. So this game altogether is not possible. So game 1 is okay, game 2 is okay, and game 5 is okay. Determine which games would have been possible if the bag had been loaded with only 12 red, 13 green, and 14 blue, and then some of those IDs. So in this case, we need to say 1, 2, and 5 and add them together to become 8. Okay, so the thing that I would do is something like this. I would grab this, then split it by this value to get the game and then the tries. Then I would get from the game this number, and then I would split these tries based on the semicolon to get each try, like so. And for this try, which is a string, I would convert it to an object to say blue 3, 4 red. Then I would do this, and then I would do this, and then in the end I would have an array of objects, which would say game 1, then an array with this object, then this object, and then this object. And then in the end I would check each row against the condition that we have here. And if it passed the condition, get the number and add it to the numbers that we already have. Okay, so let me grab this input here to begin with and go and start coding. Right, I have this for now. Save this. I'm just reading the data from this file. Okay, let me do the splitting and I will let you know how it's done. Here, after split by /n, I would filter the empty values. Then I would map to get each game and each try. If I run it here, and I need to log it, of course. So as you can see, I'm getting the values. Now I need to split this. But first, let me grab the number 1 from this one. Now if I run, I'm getting the index and I'm getting the tries. Now let's convert these to an array of objects. Okay, up to now we are getting these. Now I need to convert these to an object instead of being a string. So I would go here, do this, and this will be another map. Split everything by a comma, and then I would reduce them to an object. This object in the beginning is empty, and of course I need to return it in the end. Now for each of these parts, I need to split these by space to get these two values. And then I'm doing this like this. So in the end, blue, red, and green. So I am doing something wrong here. Okay, this should be X. And if I run it again, I am getting the values correctly. Okay, now I need to check this object against the condition. So let me first grab the condition from here. 12 red, 13 green, and 14 blue. So I would go here. Oh, I don't need this log anymore. And here I can return the game and the tries for each of the input. Now if I go and log the input, it should be the same. Let me check that one. Yes, it's okay. And let's do the calculation. Okay, I would go here. Don't need the input here. I would grab the win conditions based on the filtering of this input based on the condition that is provided. So input that filter the winning condition. But how we could do that? We get each and every row. From each of the row we get the tries, and I don't care about the game. The tries, which is an object, not a, which is a array from an object from the row object. Then for all the tries, all of these tries and all of the values here should be greater or equal to the condition that we have up here. So we would say row dot, not row, we would say return tries dot every to cover all the conditions of each try. No, not this. Let's write try like this, so it's not a keyword. Then return object dot keys of that try to get me these values, green, red, and blue, and I would use them to get these values and compare them against the condition. Now, each of these, so another every here, every color that we have here, the try of that color, which is for example 1 here, should be less or at most equal to the condition of that color. So let me read it again. I'm getting the tries from the row, and for all the tries I would check to see if the object that keys of that try and every color on that, the try of that color is less than or equal to condition of that color. Okay, let me see what I get from the win here. I'm getting game 1, game 2, and game 5, which are the correct ones. Great. Now the only thing I need to do is add the numbers here in each of these objects. So I would reduce this whole object to a number only, ACC and each row, and I would say ACC is equal to the row dot game, and in the beginning the value is 0, so like this, and I think I would get 8 here if I'm lucky. Okay, I'm getting 8, which is correct, and this is getting 8. So now let's get the puzzle input and try that one. Copy, come here, paste it here, save, run again. 21, 49. Let's go here, 21, 49. Great. So this is part 1. So let's go to part 2 and see what we are facing for that part. Let's go here. So as you continue your work, the elf poses a second question. In each game you played, what's the fewest number of cubes of each color that could have been in the bag to make the game possible? Okay, so considering the example below, for example this part, in game 1 the game could have been played with as few as 4 red. We get 4 red here, 1 red here, so 4 red, 2 green, and 6 blues. We get 3 blues here, 6 blues here, so 6 blue, the maximum, and 2 green. So we get 2 green, 2 green, 2 green. So for each of these rows, we don't need to check for the win condition. We only need to get the maximum of the tries here. So 3 blues here, and 6 blues here, 6 blues wins. Okay, the power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. So for example in game 1, which was 4, 2, and 6, we get to 48. These are for the other numbers. We need to sum these together. Okay, so back here, let's copy this to part 2. I don't need the win condition anymore. And so for example here, when I'm getting this, I need to map this to a object with the maximum value of these instead of an array. So here I don't need the game anymore. can skip that part and this part as well, and I don't need this anymore, so I'm only getting the tries here. Okay, so if I get the input now and go to part 2, okay, for each of them I'm only getting the tries here. Now I need to say, okay, here I have red 2, I have red 4, and red 1, so red goes 4, green is 9, it's 16, so 16 wins, and so forth and so on. So I would need another map here on the input, on the tries, and here I would convert all the tries to one try with the maximum number. So I would say now I'm getting this try, and I would check that against the reducer to see if that is greater or not. So for each of the tries, get the color, and then the ACC of that color is either existing or not. And if it exists, it's either greater than the try number or it's less than that. In either way, we need to get the maximum of that, of those two values. So I need to say math dot max of two values. One is the ACCC, which is stored, or it's not stored, so we provide a 0 here, so the undefined is not checked, and then try of C. So we're checking these two values, and I believe this shall go here, like so. And when this is done, we just return that accumulator. Now let's see. Now we are getting the maximum values. Let's check it against the sample one to see if we are doing it right or not. 642 for the first, 642, correct. Okay, so we are going great here. Now we need to multiply these two values, these three values, and add them up, which will be a reduce inside a reduce. So reduce, let's call it ACC, and each row here, ACC, would be equal to the number it was before and some new value, which is the multiply of these. That is, we get the values from these and add multiply them together. And 1, yep, I think this is correct. Run this, 2286, correct. Let's get the main input and test it with that one. 71274, submit. Great. So we solved the puzzle on day 2. It has a lot of mapping and reducing here and there. I hope you have learned something from this video. If that's the case, please provide a like, comment, and even subscribe to my channel. Thank you for watching, and see you in the next video.